Good evening and thank you for joining me. I am Mr. Ish. 2x plus 1 divided by x cubed plus x squared plus x plus 1 defines a rational function we have to decompose into its partial fractions. How do you go about decomposing this? Well, look at the denominator and you open it up in terms, you factor it up is what you really do. You isolate the x squared, you have an x plus 1, and then you have this plus x plus 1, and that's your denominator almost factored. You have x squared plus 1, and then you're isolating this x plus 1. These are your factors of your denominator. One of these is a linear factor and the other one is an irreducible factor. And you know, since you have two of these, you must have two partial fractions come out. A over this x plus 1 plus, you'll have a x squared plus 1, but here you're going to put a bx plus c. You're not just going to put a b, but you'll put bx plus c because we have an irreducible factor over here. All of this is going to equal to right over here 2x plus 1, but since we're going to be generating squares over here, you can say 0x squared plus 2x plus 1 because it'll give you a placeholder. A common denominator is exactly what you see, x plus 1 and then x squared plus 1. This goes in that x squared plus 1 times, which will multiply with a times x squared plus 1 plus bx plus c. Its denominator goes that many times, x plus 1 is equal to what you see over there, 0x squared plus 2x plus 1. We just have to open up this entire polynomial right here in the numerator. I'm erasing this because the denominator here is irrelevant now. Open this all up. You'll have a ax squared plus a plus bx squared plus bx plus cx plus c is equal to all of this, 0x squared plus 2x plus 1. You have quadratic terms, or you can say squared terms, which are those. You have linear terms, which are these, and then you have constant terms, which are exactly what are marked, and these will generate your systems of linear equations. Let's look at these quadratic terms. We have a plus b is equal to 0. Let's look at the linear terms. We have bx plus cx, which is just b plus c is equal to 2, and then look at the constant terms. A plus c is equal to 1. Now you have to determine the values of a, b and c, and we can. If a plus b equals 0, we know a is equal to minus b, which you can substitute right over here. We'll look at these two terms, these two equations. We have b plus c is equal to 2, and then we have a substituting for a minus b plus c is equal to 1. You add these cancel out. You'll have 2c is equal to 3 and c is equal to 3 over 2. C is equal to 3 over 2, you put them in any of these, and I might as well just put it right here. 3 over 2 plus b equals 2, so b here must be 1 over 2. If b is equal to 1 over 2, by means of this relationship, a is equal to minus 1 over 2, and those are our values. All of this, what you have right here, will come into your partial fractions. It's going to come right over here into what you see. You can write your a like this, minus 1 over 2 over x plus 1 plus bx. It will be 1 over 2x plus c, 3 over 2 over x squared plus 1. Or you can bring all of these denominators down, and I'll want to do that. I'll do minus 1 over 2 into x plus 1 plus x plus 3 over 2 into x squared plus 1. And this can be your decomposed partial fraction for this rational function here. You see the difference between here and here? It's the same thing, except here you're presenting it in a better format. This right here is your final answer. And that's it for this particular video. That right there is our answer, and it should be good. C is 3 over 2, B is 1 over 2, A is minus half. And we're good. Thank you for watching.